Well, welcome to the latest video. So in this video we're going to take a look at putting some of the engine parts back that were taken off in the first videos, and we're going to do the rest of the timing which was started in the last video, get to the stage where we've got the carburetor on, including all the silicone and everything like that. Okay, so just as a sanity check, just a visual opening of the points is about there, and looking at that, that's very close to our 15-degree line, so we're not far away. Okay, so this is our setup. We've disconnected one end of the coil inside. We've got one multimeter cable going to ground. We've got the millimeter set to buzz, and then the other, that's the spark plug lead. The coil lead to the spark plug. So this is our flywheel with its marks on it, and that's your little timing mark there, which is a bit out of focus, I'm afraid. But so if we close the points, they're closing there and opening there. So I actually wasn't that far off. There you go, there, closing there and opening there. And they come to there, that's the end of the cam flat spot. So, and they're basically then closing again. So I should just point out that that is the right hand side set of points we got there, and we need to test the other side too. If you have a look at the plus mark there, where that is, plus mark there, that's the beginning of the flat spot on the cam. When that reaches the actual points just there, that's when the cam starts to rise. And then you can see the second plus mark there, which is the centre of the cam, and then the third plus mark, which is the end of the cam. When that gets to the points, it turns them off again. Okay, so I think we're only like a few degrees away from where it's actually set. Whether that's right or not is another thing again, I suppose. So if you look at that, this is our 15-degree mark here. If you divide that roughly by 3, you got roughly 15 there. And then this is where it's coming in. That is about 5 degrees. That's looking like it's currently set at 20 degrees advance. Alright, so if you're wondering what I did, I disconnected one end of this coil, so that isolates that circuit. You can then put your meter onto one end of the kill switch and the other end to ground. Right, this coil is not actually on there at the moment, so that leaves you with just this little circuit here with the condenser. So when the points close, which is most of the cycle, it beeps, and then when the little cam opens them up, it switches it off, so you can tell pretty well exactly what degree your points are coming in at. And then because that's disconnected, you can then do exactly the same with this side. That's not there, you've just got that wire and this, and the condenser's still in there because it's too awkward to take it out. Okay, I have now reconnected that back on. Now we have the flywheel back on again, and we've got timing marks, and we can briefly put the pull starter back on as well to help us pull it over, and then we'll see if we've got spark. Just check the coils and see if we've got spark. And that one's tightening down. That'll be enough for now. So we'll tighten that up later properly. We just need to be able to get this thing off in case we need to adjust anything. So they are not equal. You'd think they would be, wouldn't you? Well, they're not. So there's only going to be one position where these will actually work. Well, so these screws they are in better condition, not in very good condition, and I would guess I would probably try and replace them if I was really going to do this motor up for use and keep it. But this is really just a project to try and get it running. I'd be a bit worried about the reliability of something like this out at sea, to do sea fishing and that, so right, so this little piece on the top here, this is it's the key basically for, oh no, it doesn't look like a key, but it is, it's a key. It's the key for the pull start. So the pull start goes on there, and it does need a bit of cleaning up, I think. Possibly a bit of paint or something, I'm not sure. It's a bit rough, isn't it? Look at that. Oof. So if you look at our coil here, so the coil, that's the HT, which is this line there. Okay, these big chunky, this is called the core, right? The core of the transformer. Effectively, it's made of iron, because iron's magnetic, and essentially that core goes through the center of that coil there, and it's supposed to go to ground. And then if you look around, just here, that is the low winding terminal, which is this bit there. So this is like, it's called an auto transformer. So you supply energy to it through the ground with this low winding terminal, and then what happens is when you disconnect the low winding terminal, the energy in the coil gets multiplied by the windings that are above this, of which there are about 40,000 or something, and then you get a massive whack of voltage jumping across the gap there to ground. So the point I want to make, for this coil to actually work effectively, you can see that iron core has to go to ground, and there's even paint inside these. So we need to test that to ground, even that bracket to here, because that's pretty critical to it working properly. And if it doesn't work properly, that paint will make quite a difference to the state of it and whether it works or not. You have to be able to make a ground connection at this point here. So I'm trying to hold this camera while we're doing this. This area here has been pretty well cleaned. You can see if I just touch it, it's been pretty well cleaned. So if you touch this, you know, a little bit, well, it's a bit sketchy. The very edges are okay, but the inside not doing much. And if you look at the back of this, there's pretty thick paint on it. So that's got to be cleaned up, otherwise you will never make a connection with that. I'm also interested to notice that these heads, they're not steel, they're actually alloy, soft alloy. So I'm just checking these coils to ground. The reason you see it moving there is because it's a coil and it stores energy. So if you see that, it's stabilised at about 1.7 ohms. So that's the low winding. That's 1.6 ohms, which is very close. That's your main HT winding, which is 8.7 kilo. So I've got the other one there, which is 8.58 kilo ohms, which is very close, which suggests they're not faulty. So that beeping noise, that is the multimeter, which is deciding to switch itself off. That's what it's doing. Very, very fancy multimeter, must admit. Never had such a fancy bit of equipment before. Right, so this is tricky actually, because you can't really get into the back of it that easily. This is the one we had trouble with when I took it apart, if you remember. That should go on there, I believe. So that is pretty corroded, so I'd really like to replace that eventually, but I think I'm just going to run it up and down so it scrapes the bare metal, and then we'll tighten this up, and then that should coil on. This is ridiculous. The reason it's ridiculous, right? You might think I'm taking a mick, but if you were out at sea and your engine got stuck, you can't get that apart without having a bunch of specialist twiddly bits like this. So the acid test, of course, does that ground. Yep, perfect. But note that we did clean it up quite a bit. So if you want good spark, you have to have a low ohm ground. You can't have some painty bit thing going on. So if we can get this engine running, we'll probably get some leads and some better nuts and bolts for it. Probably a few other things. So pretty well connected there. Alright, so I've got a couple of plugs here. Not 100% convinced these plugs are any good, so I'm going to try them with the spark and see what happens. Might have to get some more plugs. Plugs are not expensive, they're cheap really. I didn't expect to get to this stage today, but yeah, not too bad. So if we get spark, we can then put the rest of the engine together, which is kind of nice. Maybe try and hold it. Well, that is sparking. Yeah, that's good strong spark on that. Yeah, definitely. Right, so we got spark. Putting some of these engine components back on here with the carburetor and so on. We did eventually get this hose connector off, but I had to take the plate off the engine to get it off. Okay, I'm just going to firm these because essentially, if you look at that, look, you can't even get the socket in there. Right, I'm going to use a spanner for that then. Really? Oh, that was a 19. So I'm just nipping these because this block is just pot metal. It's just soft metal. And what I find pretty astonishing is they've actually put the head on with slot head screws. How on earth you get those torqued up, I really don't know. Anyway, this one says top, and I think that is the top one. And this one says bottom, so, well, this one doesn't say anything actually, but I guess it's a conclusion you come to, isn't it? Right, so we've now got spark in those pots on this motor. These little gaps here might fill those with silicone because that's open to the water getting in if you leave that where it is. So make your engine harder to start. So we're going to start putting the gear back on the other side of the engine. So after an absolutely amazing summer, this is what we get. Absolutely dripping. Oh my god, look at this state of it. So this has been going on for 2 weeks now. I'm not complaining because we've had a very, very good year. So I was just going to quickly show you this, the inside of this engine. But it is a little bit dark in there. I don't know if we get a torch in here. You can just see the back of the rotating pieces there. So I've got torch in one hand, the camera in the other, so I can't rotate it, unfortunately. But you can see that it's pretty clean anyway. We received this today, and I don't know what make this is, but this is RTV silicone anyway. I haven't got a clue what that's for. Key of some kind. Plastic key. For some reason I expected this to be blue, but it isn't. Right, so this is going to take a little bit of squeezing, I think. There's a bit of stuff on there, like that's the one. Yeah. So I'm not going to invest in gaskets on this until we kind of know the engine starts. So same with the HT leads and the other stuff. So it's going to take, we need to do a little bit of work just to get the engine running and everything. So that should stick on there. Okay. So the O-ring that went round it, so this is it here, that has been replaced. As it was a little square shaped, so it probably wasn't running the best. The reed valves do look nearly perfect, they look pretty good. So I need a bit of RTV on that other side. So there's a T on there, so that must have been the top. It looks symmetric to me, so I don't think there's an issue with that. But so I'm going to tighten these down just to snug it, but they're going to have to come back off again for the carb. So I need to just quickly clip off the excess rubber there. Okay, so this is the choke, which the actual stem is just a piece of steel, It has to connect to the carb, so I probably won't just tighten that down just yet. Okay, so I'm going to put a very small amount. This is quite thick, heavy oil. Just very tiny amount, just so it works its way in. So the choke here, you can see the choke here is quite a grungy exterior, and we don't have the piece that's supposed to go on there for this engine, so I don't really know what to do about that at the moment. Might have to build a piece or something like that, I'm not sure. Now that is interesting because that's sitting right off there, and the choke lever is stopping it going down, which is kind of what I thought would happen actually. So I wonder if just that extra little bit where those nuts are will allow it to get the clearance, maybe, something like that maybe. Or maybe that's what you do, maybe you just push it forwards like that, something. Still, that's still quite... Ah yeah, there you go, look. Yeah, that's how you do it. I knew there must be a way, otherwise they would never put the engine on the market, right? Right, so just to show you that's your choke. So your choke doesn't completely close, it just chokes. That's why you got the hole there and the extra bit there. And then just here you've got the main part of the carb, which is actually quite nice, surprisingly. If you look at the exterior, you wouldn't expect that really, would you? So if anyone wants to know, the carb is made by Bing. It's just there, and there's a number on it, 62115. Okay, I'll make sure we can get the choke on there. That's good. So I got this nice new shiny, look at that, beautiful, from the old boot sale. 10mm, because my old one was getting a bit rusty, so I thought, well, I'll have that. Cost me £1. Where else do you get spanners for £1? Brilliant. So part of this is a reaction against, because you see a lot of YouTube shows where they've got every bit of battery operated drilling machine or whatever that you can think of, and new sets of snap-on sockets and all the rest of it. You don't need to do that, and I think there should be somebody there promoting that somewhere. You gotta recycle stuff, folks, if you want to still have a world in a few years' time. That's your choke fully out, that's your choke fully in. There may well be a pin goes on there, but I can't see that coming off. Given that it was quite hard to put it on, I can't see it coming off. Well folks, that brings us to the end of this little section. Look out for the next video where we'll continue putting the engine back together. That's our choke, if you pull it right out, it goes pretty much where it should. That's interesting. So, thanks very much for watching folks.